Okay, welcome to Planet Geography. We're looking at the 4 layers of the rainforest. They are the forest floor, the understory, the canopy, and the emergent layer. Okay, so let's start by looking at the forest floor. The first thing you need to know is that whilst rainforests are found on the equator, and therefore they receive a huge amount of solar radiation, only about 2% of that solar radiation makes it to the forest floor, okay? And that's because it's absorbed and captured by the canopy, which we'll talk about in a second. So they tend to actually be very dark spaces, okay? The soil is nutrient poor, okay? Mainly because there is such large uptake. If you know the nutrient cycle, check out my video on that if you haven't seen it. From plants, the soil tends to be quite thin and quite nutrient deficient. That's why it often takes on a red color and not a brown color. The types of animals you see here, sorry, not animals, plants you see here, is often fungi. So this is a mushroom. Okay, you're seeing fungi and you're seeing moss as well. Okay, and that's mainly because it's such a, here's my moss. And that is mainly because it's such a damp and humid space that it's perfect for this type of plant life, okay? Decomposition happens very, very quickly. Vegetation, animal matter, dead animals and so on, they decompose very, very quickly and they're broken down because it's perfect for bacteria. It's hot and it's humid. In terms of the animals we see down here, on the forest floor, it tends to be kind of anteaters. So here's my anteater. Here's its tongue for the ants. Naturally, if you're going to get anteaters, you're going to get lots of ants and bugs and insects like so. And you also get, this is the one I want to kind of point out, you also get jaguars. I'll draw my jaguar down here, okay? Now, why is a jaguar a good example of a forest floor? The reason being, God, this is a terrible jaguar, is because they are camouflage. So check out this image of a jaguar and you see that it's kind of brown and with the black spots. And that is literally just to copy the forest floor, because the forest floor is brown with dead vegetation and then lots of dark spots on it from all the shade that is being created by the canopy, okay? In terms of plants, they tend to grow very quickly. So they need to go from seedlings, tiny little seeds, to reaching the canopy layer as quickly as they can, okay? They've only got a certain amount of energy to do that. And if they don't make it to here, there won't be enough sunlight, there won't be enough photosynthesis, and they will, die before they get there. So this is the forest floor. The key things you need to know: receives a very low level of solar radiation at 2%. Anteaters and jaguars are your big animals that are known there. Camouflage is the big animal adaptation. Vegetation takes the form of fungi, mushrooms, and moss. And yeah, I think that's it. I think we can now jump into the understory. Okay, so let's look at the understory. The understory generally is considered to be about 5 to 25 meters above the forest floor. Staying with that idea of, well, how much solar radiation does it receive? Because again, this dictates how much photosynthesis can take place. We kind of find about 2 to 15% of the total sunlight that hits our rainforest to actually reach this layer. And as a result, this area is dominated by shrubs, so kind of bushes, and what we say is saplings. These are juvenile trees, so kind of teenage trees, saplings. And they are all desperately trying to make it to the canopy. And in reality, 98% of saplings, they die before reaching the canopy. It is just so competitive within a rainforest. There's so much life taking place. There is simply more life than there is solar radiation. So most of the saplings die, okay? But those plants that do survive in this environment, let's draw kind of a shrub here, really, a kind of a small tree, if you will. The leaves they tend to have are big leaves. These leaves are trying to absorb as much solar radiation that there is, as much sunlight as possible. Okay, so that's one plant adaptation, is they have big, broad leaves to try and catch as much of the solar radiation that is there. The animals we find are frogs. There's my frog, kind of poison dart frog maybe. You're going to find quite a few snakes as well, okay? Perfect for reptiles because it is moist and it's humid, it's warm, but it doesn't get too hot, it doesn't get too cold, so it's perfect for reptiles. A lot of the animals here are nocturnal, they hunt by night, and the trees are desperately looking for light gaps. So light gap is basically when a tree dies, it will collapse and suddenly there will be a hole in the canopy and all the saplings will race up to that light gap. It's a nice tier 2, kind of tier 3 terminology for you. All right, so that is the understory. The big takeaways there: 98% of saplings, juvenile trees, die in the understory as they try to reach the canopy. It receives more sunlight than the forest floor at 2 to 15, but it's still not huge amounts. Okay, now let's look at the canopy, the most important layer, I would say. Okay, the canopy layer. I said it was the most important layer of all. I'd kind of say that. My argument for that would be 98% of life in the rainforest. And remember, rainforests are packed with life, are found in the canopy. We find it at 25 to 45 meters. And it is a continuous layer. Continuous means uninterrupted. It's a continuous layer of vegetation, all right? And this allows animals, such as monkeys, and snakes, and sloths. Here's a sloth hanging and sleeping. Yep. It allows them to live continuously in the canopy. Okay, they never really need to leave. Sometimes they might need to come down for minerals, but that is literally it. They can spend 99% of their life in the canopy. All right, linked to that idea of 98%, it receives about 98% of sunlight. So it is greedy, it's taking up almost all of the sunlight available. Okay, and that's because there's nothing blocking it. Maybe the emergent layer, which we'll talk about in a second, but 98% of it. And these plants are greedy. They want as much sunlight for as much photosynthesis so they can grow as large as possible, produce as much seeds as possible, and continue their evolution. In terms of the plants we see here, it's epiphytes is what we see. These can be defined as trees growing on trees, which sounds kind of mad. But what they will do, these plants will grow on the trees. And so they will grow on branches, and they don't have roots that touch the soil, which makes them kind of unique. It's a fantastic plant adaptation because the roots don't go into the soil, meaning they need to get everything they need to survive from the branches of the trees. So they need to collect the water, they need to collect the nutrients, and they need to get that sunlight for photosynthesis, all from the branches of the trees. Okay? They're not parasitic, they don't affect the trees in any way. They may just use them as a way of existing on the canopy. We also have drip tips. You know, if there's an exam question on drip tips, you can kind of use them for any layer. These are the tips here of plants. And what it's designed to do is it's designed to run the water off of the leaves as quickly as possible and get rid of the water. And that's because if they don't, it will start to rot and break down because of that bacteria. So drip tips is an plant adaptation that you can use here. And again, we get sloths. We also get toucans and parrots, all animals that you could name as living in the canopy of a rainforest. All right? So the big takeaways for the canopy is it receives 98% of the light, 98% of life, and it is a continuous layer in the rainforest. It's basically where every plant is trying to be, okay? So these are the most established trees. Okay, the last layer is the emergent layer. These are our tallest trees. These trees are expected to be kind of between 40 to 70 meters high. They are the oldest and most established trees, okay? These trees have won the evolutionary competition from this. If you think about it, only 98% of juvenile saplings don't make it to the canopy. And what percentage of the seeds that are dropped even make it to saplings? So these are the winners of the winners. And as a result, they have the privilege, I guess, of full sunlight. They get 100% sunlight, as much as they need. Probably too much, okay? And actually linking to why I say too much is they have small waxy leaves. And they have these small waxy leaves because the sun intensity is so strong. If they have big leaves, they will just simply lose moisture through them, when they'll have to cool themselves down for transpiration. If you see my video on the water cycle. Okay, so they have these small waxy leaves to stop that. They are vulnerable to lightning strikes, which I will draw in. They are vulnerable to lightning strikes and during storms, strong winds as well. And that's why they tend to have huge buttress roots. Okay, these roots, and I'll flash an image of buttress roots up now. It's a lovely example to use as plant adaptations, because what they do is they grow above the ground. Yes, the roots go into the ground, but they are above the ground too, and they act as an anchor, a stabilizer to stop the tree being blown over in strong winds. So they have buttress roots, they have small waxy leaves. In terms of the animals we're finding up here, I'm going for eagles every time, okay? Because eagles and their nests, they are vulnerable to snakes. So the higher they fly, the less likely they are to interact with the canopy and the understory and all the snakes that live there, okay? They also have fantastic eyesight, eagles. Yep, so they can see their prey very, very easily, okay? So that's it. We also have potentially bats living up here. Again, it's about safety. If you can fly, you're going to find this comfortable to live in. Maybe some monkeys. But yeah, the real animal adaptations I'm going for are eagles and their eyesight. Okay? So the emergent layer. To summarize, they are the oldest, tallest trees. They need buttress roots to keep themselves stable because they're so tall. And yeah, eagles are the animals that you tend to have adapted to live in this space. Okay, that is it. If I can find an exam question, we'll jump into that now. If there's no exam question at the end of this, it's because I couldn't find one. Like and subscribe for future videos. I'm making more and more and building up the library as I go. And check out my video on the nutrient cycles. It's really relevant to this, okay? Take care and good luck in your GCSEs.